Okay, music. Come on, music maestro.
Which one? Dramatic piano?
Yeah, definitely.
Dramatic piano.
We also have drums.
Oh, well, that's too short.
That's too
though.
quick. Yeah.
We can have that at the end, maybe. Yeah. Well, this is good. This is good. This is good.
Yeah. Yeah. Go ahead. Jesus.
Hey,
Stop.
I'm from Belgium, and my name is Ray.
Hey, I'm from San Francisco, and I'm Jay.
Okay.
Oh, fuck it. Peer pressure. This is Vijay from the Netherlands.
Cocksucker.
Hello.
What a party pooper.
Yeah,
Yeah,
we got
I
the
know,
cocksucker
I know.
motherfucker in there straight away because,
Yes.
yeah.
I think
we
we
got to
have
start off hard with this one.
We've gone soft for a couple of episodes, I think.
Yeah.
Okay.
And
Yeah.
I just put
Okay.
it in there because I know your mother's going to listen to this, Jay. So,
Absolutely.
we want-
That's no problem.
You
I think
shouldn't
she's-
have said that before.
She's a grown woman. She's
Yes,
heard worse.
exactly.
and she can form proper opinions about Vijay and Ray.
Yeah, well,
And her
we're
son.
putting all out there. We're definitely putting all out there. Yeah.
Yeah, of course. Okay, so welcome to Defn episode number 57. And this is the one, I think the first ever rhyming episode.
Yes.
Because I'm Vijay.
And I'm
and
Ray.
And I'm Jay.
Yeah.
And
So
that's
Vijay,
okay.
Ray, Jay. Jay, Ray, Vijay episode. Let's get started.
Ole.
I think we already started. First of all, I think with the shitty music and our rap. Is that rap? I don't
I
know
don't
what
count
it
that
is.
as a rap, to be honest,
It's rapping your ears in
Yeah.
a way.
Maybe it's more C-rap,
Yeah, it's crap.
Yeah.
Yeah. This is a new new genre of sounds.
It's like grime, but it's shit,
Okay.
Look, every band, when they get started, they have some rough songs. We just
Yeah.
need to iterate it.
Yeah, I agree.
That's true.
Yeah. I mean, there was some spirit there, I think there was something there.
Yeah.
VJ, I think you could put a little more into it.
I'm out of the band now already.
Let's have another go at this. Come on.
You're gonna have a talk with
Let's have
me.
another go. Before we make a start with the closure stuff, let's have another go at that song. Come on. And this time, mean it, VJ. Okay? Come on.
Ah, God.
Come on.
Okay, fine. So again, the same
The same
music.
Yeah, let's do it. We'll
Okay.
get
We don't get paid by the minute
we'll
anyway.
get Jay
so-
to start it this time from the West Coast.
Oh,
Okay.
I was gonna throw VJ.
Okay,
under the
no,
bus and
okay,
have him do it.
we'll go.
Because he's the one on
That's true.
probation.
Yeah, we'll go east to west. Okay, we'll go east to west. VJ, you're starting this time.
Dude, if it is east to west, you should be
No,
starting
you're further
because you're
east.
Easter to me. I live
Yeah,
in the
that's further
Netherlands.
east than Belgium. Yes.
Is it? Okay. Oh, fuck it. Okay. Here we go. Hey, this is Vijay.
My name is Ray.
Jay. The music stopped.
What the hell,
VJ?
Okay. Well,
Well, VJ, I think that
I
was a
think
much
so.
better effort.
Yeah.
So maybe we could splice the two of those together and come up with something that's useful.
I mean, that's going to be a horrible merge commit. That is, let's be honest.
Oh,
Oh, that's the merge of nightmares. It really is. It's a three-way merge of horror. BJ, say something. Are you still alive after that?
no.
Oh,
I think I took a lot out of him.
Did it work?
it worked. I don't know if it worked.
Ah.
The music seemed to stop.
Oh,
Yeah.
okay. I don't know. Maybe this is probably like a small bit or something.
Yeah, there was something weird on the DJ front there, but I thought
Jesus.
I thought
Okay.
you were just cutting us off.
No, I think something happened with Zencaster. I think it couldn't tolerate our awesomeness.
I mean, that's
Gave
a bit
up.
weird, isn't it?
I
Really,
see.
because I thought we were approaching Zen there. It was
Yeah. Okay.
especially Jay
So-
at the end. I mean, it was very Jay. It was good.
Oh.
Yeah, there was
Nice.
something spiritual there.
Ah.
Thanks, Ray.
Oh, well,
Thank
yeah.
you.
So, I think that's all we have for this episode, I think.
Thanks for having me on, guys.
It's an absolute pleasure. I mean, we've achieved
By the
enlightenment.
way,
What more can
go
we ask for,
Clojure.
really?
I like how you're trying to put some sanity into this, Jay. We're like, oh, go Clojure. Oh, okay, come on. We'll talk about Clojure later.
I hope that when I achieve enlightenment, like my hair grows back and is like
Yeah.
witches.
Right.
Because like, how can you have enlightenment without hair?
That's true.
Like that?
That's true.
I think that when you look at these Buddhist monks, they're probably doing the same thing. Like, they're making their wishes on
Yeah, so they can have the real hair like that. That's true.
Right. And I think they're starting with a clean
Yeah.
slate, both like physically and like metaphysically.
No, I mean that's the Zen story, right? I mean, you can't fill the cup when it is full, so you need to empty your cup before you go to the Zen master. So it makes sense. So you need to shave your head first and then grow back into Richiki's.
Yeah, you have to give up all your possessions. That includes your hair.
Right.
Yeah, and also your old programming languages and ways of doing things.
Absolutely.
Yeah. So
Excellent transition.
So let's get started. So what did you give up, Jay, in programming languages to come to Clojure, and why?
Sure. Yeah. So I started with Just Basic, and I have no idea why. Just Basic was a free version of Liberty Basic. I don't know why I used it, but it was a good way to get started. I was writing like text-based games, and then that went into like Dark Basic because I wanted to do like 3D games. I was just big into games, and then from there, I mean, that was like 6 months in or something. I was like, well, I was online. I was like, what do people write when they're really serious about games? Like they want to make like the best games, and the answer to that was C++. And I was like, okay. So I jumped right in to C++, and for the next several years, basically just did a lot of C++, and was all about it. And the thing is, C++ is a massive language. People don't realize, I think, just how big C++ is. I think you have a lot of people who call themselves C++ programmers because they can write. I mean, and in some sense they are, but they can write C++ and it compiles and it runs and it does what they want. But they're probably using a tiny like fraction of the whole language. And I've spent several years using C++, but there are still entire parts of the standard library that I've just never really even thoroughly used. So anyway,
that is pretty much similar to Richiki's journey, right? Because he was also a C++ programmer, and he wrote a couple of papers in C++ and libraries and whatnot. Yeah.
Right. Exactly. But I'm not drawing that comparison. So
we will make the comparisons here.
But
this is our show.
Yeah.
were you enamored with the standard template libraries, Jay?
Right. So actually, it's not the standard template library. It's the standard library, which is the standard library was based on the standard template library. So people call it the STL, but it's the standard lib. STL was something that came prior, and then the standard lib was built based on the STL, which is also not to be confused with STL, who's a person who actually works on, I think, Microsoft's version of the standard library. It's like this.
Have we got Strauss up on the cast here? What's going on?
Anyway.
Welcome to C++ podcast episode 1.
Yeah, so
it's level set here.
Yes, it did. And anyway, I was really big into it, and I think most of my GitHub repos would probably be in C++ or around C++. And I think including most of my more popular and successful projects have all been around C++. And I was really interested in trying to squeeze that. I am arriving somewhere with Clojure here. I was really interested in trying to squeeze as much as I could out of the language, out of C++.
Just before we go on, Jay, just interrupt you for 1 second. Is like, was this all kind of in service of some hobby, or was this when you started work, or what was the context of this learning?
Yeah. So, well, when I started learning C++, I was still in high school,
right?
And then, like, I was really fortunate to be. I grew up in like a really, really small town. There were 50 people in my entire graduating class, and I was fortunate to be like shipped off to another school, like on a bus, like 3 days a week, because it was a bigger school and they actually had an information systems technology class.
Right.
And I would go there, and most of the people there would like look up erection on Wikipedia and snicker like all day long. And I told my teacher, like, I want to learn C++. I want to write games. I want to learn OpenGL. And she was like, okay, like, do it. We will forego the whole typical curriculum of what I typically put people through if you show me that if you're progressing and you're getting better. And that was amazing. That was like a really nurturing environment for me to just learn everything, fuck up in so many ways. I realized that when I look back now, the code that I was writing then, this is really cool. The code that I was writing then, because I didn't really understand, even though I was writing C++ and technically, I didn't really understand like the control flow of functions and like unwinding the stack.
Right.
And so what I would do is I would get into some functions, and when I was ready to come back, I'd call main again.
Oh, okay.
And so I would re-enter main. And then obviously if you re-enter main, you don't want to enter a loop. So I would keep some global state that I would mutate so that when I re-enter main, it puts me into a different path.
You were writing a virtual machine.
And then yeah. And then every now and then the stack would blow, and then you restart. And such is the engine of reality. So that was really great. And then I went to school specifically to study game development, and that was all in C++. So when was
there a school that did that?
Oh yeah, there are a few. So this one I went to is it's called Full Sail University. It's in Central Florida, and it's if you're dedicated, I think it's a great school. I didn't actually finish. Because I was doing open source work all the while, and I was offered a job before I had finished, and was like, fuck it, I don't want to finish school. And I probably didn't have the money to finish school anyway, because Full Sail is not cheap.
In America.
And in America, exactly. So I took the job offer, which was like a terrible salary, but was amazing for me. But Full Sail was really cool because they try to make it as like real life as possible in the game industry. And so you'll be in the middle of like a game project, and then they'll spin a wheel of misfortune, they call it, which is like, oh, the product manager has decided that you need to add localization to your game, or you need to write a development blog or something like that. And then the other thing was the school, it's open like 24/7, literally. And you have classes like 8 hours a day. You'll have like a 4-hour lecture, 4-hour lab, but there are all sorts of hours. So you have like a 3 a.m. class, and their idea is that you just go nonstop like this, like 24/7 for 2 years straight, like with no summer break, basically. And you get a 4-year degree.
Why don't you get anything like this when you type Florida man goes to school or something? Like, whenever you type Florida man in Google, there is nothing that shows up like this. Like people going to school at 3 a.m.
It's
crazy.
Yeah, it's all alligators and
It was good. Yeah, and a buddy of mine told me about it, and he was like, "Yeah, I want to go here. I'm certain about this." And I just sort of like hitched onto his dream.
Nice.
And then that ended up working out. But anyway, So yeah, I got
What were
offered
they
a job.
teaching you there, Jay, by the way? Was it like was it like physics engines, or was it like gameplay or design or what, or everything? Yeah.
All of the above, man. So you start off with we actually, like the first class, you don't actually start off with C++, you start off with Lua, which used to be Scheme.
Okay. Yeah.
But those fuckers were, they didn't want the parents, I don't know. But they went to Lua. And anyway, so you start off with Lua to just sort of get your feet wet with some programming. And then they jump you into C++, like right away. And then you stay in C++ for the entire thing, but you start off with like writing some text-based games, enter a random number between 1 and 10. Did you guess the right number, sort of thing? And then you move into graphics programming, and then they handle. You have classes on multi-threading. You have classes specifically on DirectX. You have classes on how to use like certain game engines, and also like the 3D content pipeline for what you'll actually expect to have if you go into a game studio that's using Unreal Engine or Unity.
Right.
So that way you can understand, well, how do the artists make 3D models? What are vertices? How are triangles, how are triangles formed, and how are models built from triangles? Like how are they unwrapped, and how do UVs map to them to texture things? How do normals work? Everything like that. So like you get to understand that side of things, so that when you're working with the artists, you can be useful and you can understand what they're doing. Yeah.
Did you get some hardware kind of stuff as well, like all the graphics cards and those kind of things, so that you could be optimizing for that kind of stuff?
Sure. Not really. I think it was mainly software oriented. Everyone had a Windows laptop. I was like the only one in my class that had a Linux laptop that was dual booting Windows and using Git. So like everyone is just sort of learning to program on their Windows GPU, and there wasn't really anything that went super low level. So it was mainly that, and then just learning to work together in teams to actually ship a game, and having to deal with the issues of like being assigned with random teammates, and one of you has to make the animation system. You have to make it from scratch, like 3D skeletal animation system. The other one needs to make the like the sprite based
animation.
Oh god, I can't think of the like emission exactly. What is the I can't. Okay. Anyway, one of you has to do that, and then the other one has to build some sort of UI system that scales properly. Or whatever. So it was a whole lot of that, just sort of rinse and repeat, make it more and more complicated. And now you add networking, then you add threading, etc. To you finally get to your final project, which I didn't get to, but so it was a whole lot of that. All the while I was doing open source game engine development for the most part.
Right.
I was really interested in sort of low level, make a game engine, optimize every single aspect of it, try to parallelize as much of it as possible. And I was doing that. It was all on GitHub, and some recruiter found me and was like, "Hey, how about you come over to San Francisco and work for us in this game company?" And I actually had a buddy of mine that I used to hang out with, who was also at Full Sail. He went and interviewed at the same place, and he came back, and he didn't get the job, but he told me everything about their interview process. And he said, "Okay, so their coding test is Conway's Game of Life.
Okay,
you need to be able to write that." And I'm like, "What is this? Yeah. I don't know what Conway's Game of Life is, right?" And then I look it up, and obviously, I mean, everyone has to know what that is. So if you don't know what it is and you're listening to this, go figure it out. But I wrote Conway's Game of Life over and over and over and over again. And I did console versions, I did graphical versions of it. And then I went to my interview, and I was like, "All right, so what am I going to be coding today?" And they're like, "Well, have you ever heard of Conway's Game of Life?" And I was like,
no, never.
I was like, well, I said, I have heard of it. And they're like, okay, so we're going to have you program that. And I was like, okay. and so I did it, and I got the job.
You just glided through.
Yeah.
Yay. Very, very well done. Very well done. I did. And I got the job. I lucked out, actually. I think that the head of engineering was from Maine as well, which is where I grew up. Right. And there are only like 5 or so people left in Maine. Like the rest of them have gone somewhere else. But I happened to have one there who's the head of engineering. And so he's like, oh, I heard you're from Maine. And he's like this brilliant, brilliant guy who's asking me terrible questions, like terribly difficult questions that I know for a fact I didn't get right. But I think because I had that in, I got the job. So it's like I had that in, and then I knew the coding test. Yeah. And because those 2 things lined up, I ended up getting the job. And then from there, no degree, getting paid shit, but and I had absolutely no money. Like when I came out, I know we haven't arrived at closure yet, but this is fine.
No, we don't need to.
It's okay. We've got time.
Exactly.
When I came out, I had no money, and they this company that I was hired at, TinyCo, they put me up with someone else who was also just hired, and we ended up being roommates together. And his dad basically gave me a loan to get some like furniture and stuff, and to be able to pay rent. I couldn't pay anything. I had no lights in my room. I had no bed. I had the pillow and the blanket that I took from the airplane from my flight over from Maine, and that I slept with that for like 2 weeks until I got my first paycheck, and then at that point I got a mattress, and then for the longest time I still didn't have lights in my room, but eventually paid everyone back and started saving some money, and then it was a rough start.
That's just game of life.
It's a real Dick Whittington story,
Yeah, it was. Money was was also in full sales. I was running super low on cash, so the whole job offer thing was so nicely timed. I had a buddy of mine from IRC I was hanging out on. I still hang out on Freenode several years or a decade later. But one buddy of mine I was getting to know sort of knew the state that I was in, and would buy me pizza, would order me pizza and ship it to my to the house that I was staying at, because he knew I just didn't have the money to buy much food.
That's nice. That is very generous. Yeah.
So it was through everyone else's generosity that I was able to finally make it to San Francisco and prove myself as a developer.
Perfect. I don't know.
That's really nice.
But anyway,
I think we have peaked. I don't know where to go from here. Okay, it's all downhill from here. So
well, we still have closure to get to.
Yes, exactly.
Well, I think the good thing is that it isn't a kind of midnight cowboy story, because that would have been really bad.
I don't even think I want to ask.
Oh, Midnight Cowboy. It's a Dustin Hoffman, John Voight film from the sort of 70s where, small town guy goes to the big city, and it doesn't end well.
Okay. Ooh.
Well, he's here on the podcast.
Yeah, no, right. This worked out all right. So I stayed at TinyCo for a while, and I was getting really into C++, specifically template metaprogramming. And the reason was that I wanted to try to squeeze as much out of the compiler as I could. And the thing about template metaprogramming is, I think if you put 100 C++ devs that you just take randomly in a room, you take them randomly from, I would say probably not even the game development industry, but probably just any industry using C++. Take 100 of them, you put them in a room. I would think that maybe 5 or fewer are going to be comfortable writing template metaprograms, or talking about type traits, or SFINAE, which is substitution failure is not an error, and the patterns that these terrible acronyms that comes out of C++, like RAII. But I was getting really into that, and I was like, that was my job security as well, because I was writing C++ that nobody else in the company like
could figure out,
felt comfortable with. And there's like, oh, there's an issue with this thing. Okay, we'll need to have Jay look into it. He's doing this other thing right now. Let's add it to his queue. And honestly, that was great, because that's like, established myself there. But I hit a point where I was trying to get more type safety. I was trying to get more just sort of safety in general. Like, the reason I was doing these template metaprogrammings was I wanted the APIs that I was making to be as type rich as possible, so that hopefully we fuck up less, because we had hundreds of thousands of lines of C++ code in just the game engine alone. TinyCo had their own game engine that they built in-house. And then you had like 100,000 lines of code for the games each that were built on top of that. It's a lot of code, and a lot of things would go wrong. And so I was trying to do that to squeeze as much out of C++ as I could. And I was moving towards something, and the C++ compiler was fighting me. And I didn't know what I was moving toward, but I knew ultimately that C++ wasn't going to offer it to me. And that I had basically squeezed the last drips out of it that I could, and I had to look somewhere else. And so I started looking into Rust, which was super new at the time. And I made like a game engine in Rust that it took like Quake Live maps and Quake 3 maps, and then using separating access theorem, it voxelized them. And then the idea was to have like a Quake 3-like game with voxelized destructible maps. And so I was doing all that in Rust. It was way too early in Rust, because not only was the language changing so much, like literally every week, but the libraries were too as a result. And so it's like, oh, okay, this one windowing library completely changed its API 3 times since I was working on this engine. And it's the same thing for the OpenGL library, and it's the same thing for this and that. So ultimately, it just really wore me down. But I think it was a good taste of something that offered more than C++ in terms of data management, in terms of like expression. So you like Rust has pattern matching that C++ just doesn't compete with, and I think better approaches to concurrency, both parallel and otherwise. Vijay, I know you said that you've been looking into Rust as well, so you I know what I'm talking about with a lot of this. So I was looking into that, but it still wasn't a far enough departure from what I wanted. But I didn't know what I wanted, and so I just sort of started researching some more, and I found out that what I wanted was functional programming. And so it was like, boom, that was added to my vocabulary, and then all of a sudden. I realized I don't know shit, and there's so much more for me to take in. And I was like, all right, so I got to pick up a functional language. And we had one loony in TinyCo who's really smart guy. I say loony affectionately. We had one loony who was all about Haskell, and he was just constantly going on about how everything we're writing in C++ was crap, and it needed to be Haskell. And I didn't understand really. I was just like, okay, he's a loony. And then he eventually he couldn't take it anymore. And then he left. And I think, I hope for his sake, he's writing Haskell these days.
Or telling other people that Haskell is better.
Maybe he's Idris,
Probably.
Yeah. Or maybe he's forgone the types and he's enjoying Clojure.
Probably.
But so there was that guy, and I was like, okay, so I know Haskell, and I know one loony who's into that, and I looked into that, and I was just like, I can't do this. Like, I'm not good. I'm not smart enough. I'm just not good enough. I don't know. This thing's beyond me. And I was like, if this is what functional programming is, it's not for me. Because I need to be able to I just need to be able to write some fucking code, man, and make it work. And like, I was still writing game engines. I like writing operating system kernels. I like writing kind of low level things, but I want to be able to do it in a way that is as safe as possible. And anyway, so I came across Clojure, and I was like, okay, all right, so this is functional, but I can just sort of write imperative code too.
Yeah.
It doesn't feel, because it's not declarative, or at least like, it doesn't have to be declarative, right? You can just sort of get in and say def in main print line, and that becomes really easy. And then it's like, okay, now I can just start doing some mutation if I want. And
did you re-enter main as well?
No, I did not. By then, I had broken that habit. But thanks for checking.
That's a shame, actually, because I think it would have been nice, would have been fun to do.
Right? Not with Clojure's stack issues.
Yeah. No. I mean, you would have got the worst, especially when Spec came out. With 1.9, you would have got like your error messages would have been like the talk of the town.
Yeah. Exactly.
But
I would have needed.
That's a big departure, right? Coming from C++ and then thinking about types and everything, and then low level code, and then switching to JVM and Clojure. So
I was awful.
Was it a culture shock?
It was. I don't know how I made it through, because the thing is that I didn't know what I was doing. I was just like, this is a language, I'm going to try to write something in it. And I had no idea what I was doing. And so the thing is that, to make it even worse, what I had done was I had hit that point with C++, and I was looking into these other languages, and I didn't find anything that I really liked. And so I had decided I'm going to make my own language, right? I have these ideas of what I have in my head. I have these things that I really don't like with these other languages. I'm going to make my own, and I'm just going to address all my concerns. I don't care if other people don't like it. This is for me. And so that started several years ago. And I originally wrote it in C++, and it was a nightmare to maintain and everything like that. It was fast to compile the actual code. It wasn't fast to compile the compiler, but it was a pain. So as I started looking more into Clojure, and I kind of progressed a bit beyond doing foreclosure challenges, and asking like Clojure golf questions in the Freenode Clojure channel. It's so funny. Clojure is a unique programming language because it's the only one that I've used where and throughout this time, it's primarily C++, but I've used a lot of other languages as well, just for things here and there. But it's the only one I've used where if you ask a question in the Freenode channel for that language of how do I write this, how do I do this one thing, you end up with 30 minutes of everyone in the channel contributing like different examples of how to optimize not performance, but instead like laziness or expressiveness or something like that. And there was so much of that, but it was really helpful because I would just watch like someone be like, oh, how do I do this map with an index? And then someone would be like, oh, use map index. And then someone else would be like, oh, use like use list comprehension. The other one's like, oh, use a reduce and do it like this. The other one's like, oh, what about transducers? Or something like that. And then I'm just like, whoa, I'm taking, and then I'm taking all this in, and so I was taking all this in, but I hadn't made anything useful with it. And so what I did was I rewrote the compiler for that language I was making with Clojure, and it was absolutely terrible. I did such a bad job, but it was helpful, and I ended up rewriting that compiler again in Clojure, just having learned. Like how to keep an AST as like one big map, and then how to like transform that thing in place without mutation, because compilers can absolutely just be a pipeline of data transformations. But when you come from C++, you don't think of them like that. You think of them as objects and hierarchies and whatnot. So I didn't have the right mindset. And anyway, so I had I'd gone to Singapore for a while. I came back, and I was doing mostly C++ there, a lot of C# actually as well. And I came back, and I went back to C++ programming, but I told myself, at that point, I had been writing C++ professionally for 5 years or so. I told myself, this is my last C++ job. I'm going to take this job because I need a job right now. I need some income.
Sure.
My wife and I needed to come back from Singapore to San Francisco, and we just wanted some stability. But I said, I'm going to look for a functional programming job, and as soon as I find a good one, I'm going to leave C++ behind, and I'm going to move on. So for the next year, I spent time looking for the right job, and also one thing that I was really into was educating people about C++. So the thing is, I was the C++ guy that everyone sort of went to. But even then, I still admit there are so many parts of C++ I didn't know, but still, where I was working, I was a C++ guy. But ironically, I was the one telling everyone not to use C++.
let me teach you C++.
Right?
Okay, don't use C++. So that was the conclusion.
Yeah, absolutely. And so
not even to a secret here.
My parting gift to them was the last talk. I would give talks about metaprogramming. I would give talks about. I gave a talk about Clojure actually, which wasn't taken that well, I think. I actually did Conway's Game of Life in Clojure and in C++, and I compared the two. And at one point, like I had some sort of object-oriented, very imperative method in C++, and then I had shown like the sort of analogous version that used like a list comprehension, and this was probably a mistake, a juxt. And some because it's a simple enough thing once you understand higher order functions and how it's used. But when you first see it and then you have someone like explain it to you in the context of a new language, you're like, what? And then someone asked me, and he's a smart guy, whom I respect. He asked me, like, how can you debug this? Like, how is this useful? And I was like, well, on the contrary, I can run this shit in the REPL, man. This is pure data. Like I can figure this shit out. I can unit test this. I can lock it away entirely from the side effects. I can reason about this. I don't need to debug it in the same way that I would need to debug this massive if-else if block that I have in C++ that's doing some mutation. But I think it's hard to sell that argument.
But it's an interesting question, isn't it? It's a very interesting question, when you're kind of in that imperative mindset, because and I think to some extent there is a little bit of that in Clojure as well, but we can maybe come to that a bit later. But I always think, I definitely felt that way when I first started learning Clojure as well, that how do I get into these pipelines to debug them? How do I get inside of them? And, the penny eventually drops that you don't do that.
Yeah, for the most part. But it was that was tough. But the last thing I gave them was this a talk, including with a cheat sheet, which is on GitHub, about value categories in C++, which is one of the most complex aspects of the language, dealing with R values and L values and geo values and PR values and X values, and it all has to deal with the lifetimes of objects in C++, which is something that Rust sort of handles for you with the borrow checker. But it's something that you can have a lot of code in C++ that will compile and will run probably some of the time, but is actually undefined behavior and will probably result in crashes. And so that was sort of my last gift that I was trying to offer to the C++ community. That was also like here's a helpful thing to write to help you write C++ better, but also
don't write C++,
man. So the job that I found was I was offered the co-founder CTO status at a new startup, and I had complete control over what we were going to do with the tech. And I said, we're going to write Clojure. And so that is OK, Let's Play, which is where I work now. And we've patented and built an application, basically, or a service that allows gamers to bet real money on their own gameplay, their own results in online competitive skill-based games.
Okay.
So right now we're live with Rocket League. So if you want to bet real money on a 1v1 in Rocket League, we collect the results instantaneously and automatically. We handle the escrow of the funds. We handle like the KYC AML element, everything like that, so that players can trust that they're going to get their money. And you just go on there, you find an opponent, you play your game, you collect your winnings. And we've done all of this in Clojure.
And what is the stack, by the way?
So on the back end, Clojure, like your typical Clojure server, Clojure ring, and I think, are we using anything else that's very nice? We built our own in-house system for managing back-end effects, which is actually influenced by reframe.
Okay.
And so you define effects in the same way that you define events in reframe.
Oh, so you brought the front end way of doing things into the back end. Okay.
Yeah, and it's really neat. And then the whole thing's brought together in like a chain system. So you have like you define a chain in the same way that you define an event in reframe, and each link in the chain is a function that returns it's a pure function that returns a map of effects.
Okay.
And it can also pass data from one link to the next link. It can stage effects to be run ultimately once a link commits. And that's a really neat system that we built. But for the most part, that's just a standard Clojure setup on the back end. The front end, we're using Clojure script with reframe. And is there anything else? I would call out to expound as well, because that's obviously a great bit of work. But then the other thing is, for the whole thing, we have everything wrapped in Orchestra. And this was, so we started writing Clojure, and this was like, OK, Let's Play was my first Clojure, like full-time, getting paid to do this sort of thing. And I started writing this back end, and this front end, and we get to the point where we have like a couple thousand lines of code, which does a lot in Clojure, like just a couple thousand lines of code. In C++, that's like one feature. And then all of a sudden I'm like, what's the shape of this? Like, I don't know. Like, I get into some function and I'm like, wait, what keys are in this now? And we had bad habits of like not fully qualifying all of our keywords. And we had bad habits of like not always conforming shapes to be consistent. It's like sometimes this is like a partial sort of this thing, and then sometimes it's a full thing. And I was like, this is no good. And so spec came out, and I was like, okay, this is good. And so I started looking into spec, and I was looking into spec, and we started using spec everywhere. And I've read through that spec guide so many times, and every time I got to the spec gen, like the generative stuff, I was like, this is useless. I have no need for this. I think I've used it a few times, and every single time I'd be just fine without it. And then there was this other thing, the instrumentation side of things. And I was like, oh shit. We can like hook these functions to automatically check the specs. Why are we doing this? Why isn't everyone doing this? And then I used it, and then I was like, wait, it's only checking the return values? I was like, but I have all these arguments. I want to check those. And then I did some further looking into it, and I was like, they used to do that. When the instrumentation was first added, they were instrumenting the functions to check the arguments, to check the FN spec and the return value. But they removed it, I believe, for performance reasons. Which is bullshit, man.
Yeah, but
like I've been doing this for 3 years now, on the front end and the back end, and the performance change I have measured is negligible.
But compared to, because you're used to C++ level of quote unquote speed, right? And so do you how do you compare that with Clojure code? And then did you ever feel like, oh, I should have written it in C++ because it could have been faster?
Sure. No.
Okay.
No, I honestly, I've never felt that.
Because that's one of the claims that C++ people make, or probably Rust people make as well. Like, it's going to be super fast and way faster than the JVM or garbage collected languages, for example.
Sure.
Yeah.
It will be.
I think on the front end, I think on the if you're writing a game or a game engine, I think it's hard to argue the case there. But back-end services seems a bit.
Then they just be comparable. Yeah.
Yeah, so for our front end with ClojureScript, I've looked into what it would be using Rust with WebAssembly.
Yeah.
I've looked into what it would be using PureScript, and I've looked into sort of as many of the functional or type safe options that I found, and everything that we're doing on the front end is just data. Like with React, our views are just big vectors of data. And everything that we're doing, like with Reframe especially, allows us to just build everything in terms of data. And there's no language that I've used that transforms data the way that Clojure does. And so there are no, right now anyway, that I know of, there are no languages that I think I would choose on the front end instead. On the back end, we have one service that's written in Haskell. And that's...
Did you hire the Haskell guy back?
It's dealing... No.
You found him.
It's dealing with our money.
Okay.
And it's basically our money service. And there's a really great Haskell library that handles money exactly the way that we want it to. And we were really concerned about fucking something up when it came to the money with different currency types. And basically that just seemed like it was going to be worth it. Now we have several different services. We don't use microservices, but we do have different services that are all just sort of Dockerized. So it's easy enough to just spin up something in a different language and put it onto ECS.
And they all talk with each other with HTTP or okay.
Yep. And so that was no problem. Obviously, like they need to use JSON. Like most of them use Eden, but to Haskell use JSON. But with that said, I have been writing a couple of servers recently in Rust, and that's because they're game servers, and I need them to be as small as possible and as fast as possible. And so, like right now, one of the servers I've written is for a game that we're making. It runs like with a stress test on, and like hundreds of megabytes of JSON IO. It runs on a tenth of a CPU, under 16 megabytes of memory in a Docker container. And so under 16 megabytes of memory during a stress test, in contrast to our min heap size for our Clojure services is 256 megs.
That's because of the JVM and So
and so that's huge.
So all this Clojure you're writing, do you write it in Emacs or some other shit?
So I'm glad that we got here.
It's inevitable.
I use Vim.
Okay.
And I have used Vim for.
You're not pleasing anyone here, Jay.
That's okay, guys, because I'm the guest, right? And just like the customer is always right, the guest is always right. So I use Vim, and
you have never heard this podcast before.
No, actually, I've heard several, and I knew this was coming.
So that's episode number 57. Thank you for listening. And take him to the green room now.
So
let's get the music going again.
No. Hear me out. I've tried Emacs a few times.
I'm joking. Right? We're joking. No, I know. Come on, Jay.
And I've tried SpaceMax too. But there are some very big differences to my workflow. So first off, I love the modal editing so much, and it's so ingrained in everything I do. So, and also the HJKL movement is so ingrained in what I do that my window manager does that. Like I use i3 tiling window manager on Linux. I have Vim plugin for Firefox. My music player does it. My fucking PDF player does it. Like everything I have is Vim oriented.
And your car, obviously.
And I'm in San Francisco, so fortunately I don't need to have a car, but it would be,
it'll be
it would,
HJKL.
like, I would exit the car by hitting :WQ. And so so I know that can carry over to Emacs, and I've tried that. But the biggest difference is that for me, a text editor is like, the analogy that I imagine is, if I'm a field worker, like I'm on the move a lot, I'm going to different places, Emacs is a desktop computer, and Vim is a laptop computer with like radars and shit coming out of it, right? And I can, or not radars, but like antennas. That's what I want to say.
You're like a James Bond of editors, basically.
Yeah, like that. Like, I want something that I can spin up on the go anywhere that is customized for me. And Emacs is like a van that you would have to bring with you. And you can't, like, you can have a lot going on in that van. That van can do everything for you. But unless that van can go where you want to go, it's not going to work. And so the biggest thing for me is like,
yeah, I honestly don't think you should get into vans with strange people like Vijay. You know,
I mean,
this is true, especially if they're running Emacs.
No, I mean, let me. This is a teachable moment, as I say, or evangelizing moment. I think Emacs is like the time portal sort of shit. So usually, I agree with you. When you want to get onto any machine, VI is there and it makes sense. But usually, I just edit the files using Tramp on Emacs by going to the server. So I think it's more about the kind of workflow that you're used to, and then you perfect it, or not perfect, but you get used to it over the years. And it's, for me, I tried. I was trying, because we had Calva Peter on the show, and then I was giving it a try, like VS Code, and then the first thing that I did is, there is a space max simulation for VS Code, because all the shortcuts are built into your fingers. It makes sense. And so I think it's the workflow that you have, and you can take it everywhere.
The biggest thing, I think, is that if someone is writing code as much as I do, or we do, they need to have an advanced editor. And if they don't, if they're still using their mouse to move around or something like that, then it's just not efficient. And that's like, you need to fully invest yourself, in my opinion, in some sort of editing tooling, because it is the means of your whole fucking career. Do a good job with it.
I think
and so what, like Vim, Emacs,
whatever.
It's closed source, but
I've never actually noticed this before, but your name is Vijay.
Yeah, I know.
Yeah.
So you're
just need a couple of E's in there.
Betraying your own name, really.
No,
Vijay.
That means I know this.
And I'm going to start calling you. I'm going to start calling you Vijay from now on.
You should.
Just to really shut you up.
You should.
It's too bad you couldn't bring the improved version. We had Vijay.
Exactly.
And you should go like Vijay.
Maybe that's me. Actually, I should just update my name.
Yeah, just.
You should add.
That should confuse people on the internet. I think you should be Vijay and I should be Vijay, and then.
Yeah,
but
very nice.
But I think the first editor I used back in the university, I mean, we had this how do you call, like, dumb terminals connected to Unix somewhere, like you only have the dumb terminal thing, and that had the old VI, and it was fucking horrible. So that's even worse, actually. But anyway,
I don't know. I mean, to be honest, but I used VI when I used it for the beginning of my career as well, and kept going with it for probably 20 years. So I mean.
No, it does its thing.
It's okay, but I think the problem I had, you were talking about like Windows. The problem before Linux became popular, Windows became popular, and I kind of, we had to use Windows on the front end, and we always used VI on the back end. But you kind of lost the muscle memory a little bit, which was a shame. Because I loved VI, I read the manual 100 times, knew all of the interop with the operating system and stuff like that. So I had, all my own kind of bindings and macros and all the settings and all this shit. And the nice thing is, like you say, it's always on every machine. Whenever you log into something, it's there.
Yeah.
So,
And do you use a Fireplace or something, or with the VI for closure stuff?
Oh, yeah. So I have never had a good experience with Fireplace. And I mean, I think it was Tim Pope who made it. I mean, he makes amazing things. But that just never worked well for me. It wasn't until Olicle, whose name is Ollie Oliver, I think. He made Conjure, and then subsequently Propel to use PREPL. That's been the best experience I've had with Vim and integrating into a REPL. It works really well, and I have no complaints for it on our back end. I haven't had it working well with Figwheel on our front end, but we have hot reload, and for the most part, I just use like that for everything on the front end anyway. That's kind of the thing. So like I have somewhat of an adversarial relationship with Clojure. And like I disagree with a lot of the ways that people do things with Clojure, and the REPL was one of them. Like it took me a really long time to come around to the REPL, and I still don't think I evangelize it nearly as much as a lot of these other people do, because I don't think it's as useful as a lot of these other people say. On the back end, when we do have, like when I do have Conjure, it has been helpful to like just hook into some functions and say, okay, I just want to evaluate this, and I'm gonna make like a comment block and do some code in there. But I have tests. I could write a test to do that as well. For the most part, like I use a line like auto test, auto refresh. So like I just save my I save my file and it reruns my tests, and I can add some metadata to say refresh only this test, and it'll just rerun that one. And I mean, I can use that sort of like, I guess it's TDD, but not really, because it's kind of, you're not writing all your tests first and then catching up. You're just kind of doing them together. But like that is like the process that I use, and I don't think you really need much of a REPL for that.
But that's a like blasphemy.
It is total blasphemy. Fuck you.
Yeah. But I mean,
no. So I mean, well, we can. Since you mentioned you want to fight, so let's do it. Come on, because
sure, let's do
it's good to have a bit of adversarial stuff. I like this on this podcast, and we need to fight. So I love the REPL. I mean, I think we need the REPL everywhere, and it's underplayed. And I use the REPL all the time, day in, day out. And
let me get my popcorn.
The thing I wouldn't do, the thing I don't like, is all this REPL reloaded shit, because I don't like all these frameworks that make the REPL, presume to make the REPL useful, because it's already useful. You don't need all this like reloaded stuff going on. Just if you really need to restart the REPL, restart the REPL. No problem.
Right.
But for the most part, I think it's it's fantastic. Maybe it's because I don't really invest. I write the tests right towards the end. I don't write the tests as I go along. I don't like to do that, because that kind of inhibits the fluidity of the programming. Because I feel like tests are a kind of commitment to a particular shape or a particular approach.
This is true. I think that it depends what you're working. So like for example, in our backend, the way that we write tests, like we have a lot of macros to just sort of spin up like all the things that we want. The way that we write tests is really all just, it's at this point, it's so defined that it's easy to just jump in and add another one. And my concern with the REPL, in contrast with that, is that everything I do on the REPL is ephemeral. Like, so unless I'm just doing a one-off, like, I need to issue something to Mongo or Postgres, or I need to do a query or something. Unless I'm doing a one-off thing where I just want the result of that one thing, I don't actually use it to like verify, okay, this is working as I expect it to, or something like that. For the most part.
But why not though? Because that's the point.
Yeah, well, that's the point of tests too.
How are you programming anything? How are you actually programming anything?
That's the point of tests too.
Yeah.
To prove that they work and to prove that they continue to work. So I think that it's kind of serving, like, in my opinion, it's a duplicate effort. And either you're duplicating your efforts, or one of those is suffering, your tests or your REPL experience.
But why? But are you assuming that the REPL is you're typing into the REPL rather than shipping code from your editor? Because you write your program. As you're writing your program, you evaluate it in the REPL. That's how you do it.
Right.
No tests required.
That doesn't quite work. If you need a connection to a database, if you need a connection to this or that, then what you're going to end up doing is not just saying, oh, I want to evaluate this. You're going to write a little comment block that sets up everything that you need, a little fixture for you, and then you're going to write your code inside of there, and what you have there is a test.
Well, I guess, but if you just reload your namespace, you'll reconnect to a database. It's no problem.
Are you connecting to your database as an effect at the top level of your namespace?
Sometimes.
Oh, well,
not very often.
It's like we don't do that. It's always.
But normally, you should pass your database in as a parameter to your function.
Right. Which would mean you need to set that up in order to evaluate your function to begin with, which would mean you need some sort of fixture. So if we focus on that, I think we're always going to go in circles, because I do disagree with you. However, to find more common ground, I will say that I would agree with you more if I'm working on something that does not have some sort of databases or external connections or something like that.
Yeah, I mean, to be honest, I don't often use a database, so yeah.
Okay. Basically everything that we do on the back end is doing something with some sort of Redis or Mongo or Postgres, or some API or something like that. But I would say that there have been the best experiences I have had with Vim Conjure have been writing like just purely data oriented code with no effects, no setup necessary. And I can, as you said, just write some code, send it to the REPL, see that it all works, and say, great. And then worry about the test layer. So I can agree with you there. But I don't think it's not as profound as it seems to be to you or to a lot of other people.
So what is how do you architect your database then? It's interesting, because I think sometimes these, these kind of like REPL things, or like whether you're using it effectively or not, it's a kind of like whether or not your architecture is kind of REPL oriented, let's say, whether it's like oriented towards that style of development or not. Whereas maybe you have different ambitions for your architecture, or different goals, or different ways of setting things up. So, I'm happy to find common ground as well. So if that's not a priority for you, then it doesn't matter. Do
Sure.
what works.
Sure. Yeah, I just don't see how. I don't see how the REPL has anything to do with like how I design the database. Like I wouldn't design.
No, but your constant need to connect to it and take state from it, that's the problem. That's really what you're talking to, isn't it? What you're saying is,
right.
I have this sort of a set of shared global state somewhere that I'm constantly connecting to and sucking from and feeding to. And that's kind of like a peculiar architecture for me, that you essentially have externalized all of your global state, where you've got a language that has a lot of controls for that. So why are you doing that?
Interesting. Yeah. I'm going to think more about this. That's it. Obviously the state needs to be somewhere. Sure. Like we are talking about mutable state. And so it needs to be somewhere, probably in one place. But so we use our database as and our transactions as bindings. We don't use them as something that we pass into every function, just right. Because there's I don't see a point in that. But it's still something that needs to be set up. I feel like I can have a good answer to this, but I don't right now.
You know that one of the things about reframe that they try and talk about is like this side effects, but also the other thing they talk about is co-effects.
Sure.
And that's what you kind of avoid when you if you pass your database into every function rather than these bindings, then you actually have that you get rid of the co-effects. In other words, you don't have to make a lot of assumptions about the world outside of your functions. Then you can test things more cleanly than having to worry about this big ball that you're pulling from the mysterious place and dealing with kind of randomly. I think that's the conclusion I come to from a kind of architectural perspective.
But isn't that making your code more and more tedious? Like for every function you're passing, I mean, it makes sense because it's more like making the functions completely pure in a way that your function is only operating on the parameters and not dependent on anything else. But every function then that is operating on this, then it kind of becomes a bit too much.
No, because
right?
because what happens is that you end up like this like functional shell kind of approach,
Yeah.
where you definitely pass the databases into some functions,
yeah,
but that doesn't get passed all the way down. That's the whole point. Is that what you then do is you pluck some state from that database and then you start
and then pass
processing
it to the next layer.
You don't pass the database all the way down. And that's where I feel like we're kind of at odds with.
Yeah, I think I've gone through like 2 rounds of this in one of the applications that I'm working on. Like first having this model, like, okay, I'm going to pass DB everywhere. And then because there is this query layer and then there is business logic layer that doesn't know the database, but only operates on the maps. And then at some point I'm like, oh, screw this, this is, I have to pass this DB everywhere.
Sure.
And then that became tedious. And then at some point I moved it to, similar to the one that the previously Om and other people, like at the top level there is def once, and then I have something as a global state that I can pass around, like the app state sort of thing. I think there should be some sort of a balance between them, right? And sometimes it just goes like too much, and there are too many functions with DB everywhere.
Well, that's what reframe looks like. If you write reframe and you do that, Jay, so you know what it looks like, then
Yeah. Well, I have a really big gripe with reframe, actually.
Yes. Just goddamn database everywhere.
Yeah. But the thing about our database is, and then the way that we interact with it is because we use this reframe style approach. All we have is a qualified keyword that represents an effect somewhere. You're returning a map saying, I want to go run this effect. Just like in reframe, you have some effect that you need to run, you return a map that says you need to run it. You don't know how it's set up or anything like that, or what it's connected to necessarily. You just need to know there is an effect that is represented by this pure data, this declarative way of saying what I'm going to do. And then all the nitty gritty shit happens behind the scenes. I think that this is a very good way of, when you look at, one of the things that as functional programmers we try to do is separate the effects, push them as far away as you can, and just focus on the pure data transformations and your business logic. I think that given that we've done that first class, exactly how we handle the nitty gritty of that database when it's pushed all the way to the side, doesn't matter. It's not a big concern to me. But the thing about reframe, actually, the big issue that I have is that every, or one of the big issues anyway, everything is forward.
So this is going to be a series of podcasts.
C++. Now you need to come. You need to end it by telling us, okay.
Yeah.
Right, Rust.
Yeah, C++ is shit. Clojure is shit. Everything sucks except for Rick Shaky's hair. We just need to come to terms with this. But no, this is serious though. The thing about reframe is like every event goes forward. So you need to know when you dispatch an event, you need to, like, you're coupled with that event. and so it is no different from a function call, except it's just using a different syntax, right? And so as a result, what you end up with is...
And it's asynchronous, that's the problem.
I disagree with you there, because I think there's still a better way to do it. You end up... It can be asynchronous and still be better, I think.
Oh yeah, but anytime you put an event on the reframe queue, it's an asynchronous function call, is my point.
This is true. Yeah, and you're right there. For me, the better way to do it is to reverse the coupling. So when, let's say my app is focused, right? When my app is focused, I want to see if a chat window is open. And if the chat window is open, then I want to mark the latest messages as read. This is an actual problem that we had where, given the reframe design, I have some handler for the app has been focused, and then that needs to dispatch some shit like, okay, chat, go mark your stuff as read if you're visible. That is awful. To me, having to know about chat in the handler that deals with things being focused, or even if you try to separate it, like one layer or add some indirection there, still that handler there that's handling the focus needs to be dispatching to something that knows about chat. That's a problem. Now, if you invert it, then what you end up with is rather than one-to-one events, you end up with one-to-many events. So what you get is there's a handler that says the app was just focused. Now, rather than dispatching an event, what I use is the different terminology of it emits an event. Now, it emits something, which is just a signal. Now, anyone, anywhere can subscribe to that. So the chat system would say, I'm interested in when the app has been focused, because I want to update the read status for these messages. To me, that is a much better architecture, but it is entirely prohibited by the design of reframe, because you don't have these one-to-many events. Now, you can implement that in reframe yourself, but it's not...
Well, just 1 second. You can have multiple subscribers to an event in reframe. That's out of the box. So it's no problem there.
I'm thinking about how I want to word this.
You're really full of shit, Ray. You're allowed to say it, you know?
No.
I'm factually correct.
I don't think that at all. No.
I could still be wrong.
So the thing is that when you think about these things, you have to change the way that you're thinking about your reframe events then. Because if you think of them as asynchronous function calls, then that's absolutely not the way that this can work.
Mm-hmm.
No, but my point is that, let's say, you do this focus effect, like on some component, it's focused. You can emit an event, like you say, that says, okay, something got focused and this is its name, and then you can have a subscriber, and that subscriber can filter based on those events, and you can have 100 subscribers.
And what do you do? Are you doing that with interceptors?
Just subscribers, just standard reframe subscriptions. Yeah.
Subscriptions are different. Subscriptions are the bridge between the event layer, the model layer, and the view layer. I'm going to say that I don't understand what you're saying, and I don't think that there's just a way to arbitrarily subscribe to something. When you dispatch something, you are dispatching the name of an event to the name of a function to go call, and you can have interceptors to intercept those, but that's not a one-to-many. That's I'm going to be a man in the middle for this one very coupled event. And subscriptions are just a way of providing data from the AppDB to the view, which is, as far as I'm concerned, entirely separate from that. So I don't understand how you're saying that can work.
So
and it could just be that I'm missing it.
Well,
or I'm
but
I'm behind. I don't know. But either way,
no. Well, it's the way I've used it in the past is that you do these subscriptions, but maybe I'm doing it wrong. I could be holding it wrong. That's for sure. Yeah.
So you're using this for so this is for a chat application that you built for the gaming stuff that you have. That's the front end mostly.
We use Reframe for the entire front end.
Okay.
And so that's we're on mobile and desktop and web, and it's all just ClojureScript and React. And we use Reframe for the whole thing.
But mobile as in mobile app or just a mobile web thing?
It is a mobile app that it's called a hybrid app. So it's a native app that loads up a web view basically, and then uses Cordova to talk between the two.
Oh, okay. So it's not React Native, but Cordova.
No, it's not React Native. And the main reason is, although React Native is similar to React, they are too dissimilar to, I think, comfortably share code bases with something that is React.
That's true.
And there is React Native for web, but all of that can be avoided if you just use a hybrid app.
Yeah. Okay.
Yeah.
And so how much of code sharing that you have between ClojureScript and Clojure? Is there common libraries in CLJC somewhere that you use in both places?
Sure. Yeah. So, I mean, our whole front end is ClojureScript, and then our whole back end is Clojure, except for that one Haskell service.
Yeah.
We do have a common code base, which is primarily just filled with specs.
Okay.
Makes
because
sense.
as one of the things I mentioned was we just spec everything. And that's because we, for both the front end and the back end, we're using Orchestra for everything.
Yeah.
And there isn't that much, there are some helpers that are shared, but there isn't that much that's shared. But the thing about Orchestra, I want to come back to that.
Maybe you can give us a kind of for the people that don't know what Orchestra is, Jay, maybe you could give people a kind of 5-minute introduction to it, because I think it's pretty special, So I think you've done a great job there. So it would be good to give people a level up on just a 5 minutes on what the background there is.
Thanks, Ray. So yeah, Orchestra is a Clojure library that uses spec and instruments your functions by basically hooking your functions so that whenever you call them, automatically all of your inputs and outputs have their specs validated. And that means that assuming that you have spec'd out not even all of your system, but a good portion of your system, you'll know, because you'll get a spec assertion failure whenever you make a function call and some data is not in the shape that you expect it to be. You'll know right then, rather than later when you get a nil somewhere and you're wondering what the hell happened. Now, Orchestra works with Clojure and ClojureScript, and there have been some concerns raised that the performance of this instrumentation is worthy of not running it in your everyday development or in production. I mean, I've had people say you can't even do this in everyday development. It's absolute bullshit. You can. In the measuring I've done, it was I think 3 or 4% of our startup time for our app during development is instrumentation. And to know that every single event that we're dispatching, in the case of Reframe, because we spec all of our events, to know that every single one of those has the exact shape that it's supposed to be is absolutely worth 4% of our load time to me. So Orchestra also provides a macro for to wrap defins in a C style way where you get to say the name of an argument and then follow it with the spec for that argument in line, and also specify the return spec. It's called defin spec. So we use that, and then we use macros around reframe events as well to use the same syntax for our reframe events. But I recommend that anyone who's doing Clojure, who's already using spec, who wants to have more confidence in their system, give Orchestra a shot, because it's just you hook it in, you call instrument, any functions that you already have instrumented are just gonna be automatically checked. If something's bad based on the specs, the invariance that you're asserting based on defining your specs, if anything's bad, you're gonna know. And you wouldn't otherwise know unless you manually assert all of that stuff, which is just not feasible.
Yeah. And so maybe a completely different question. So how long did it take for you guys to bootstrap pure, because I'm assuming this is OK, Let's Play is a completely new startup, right? Like there is zero code, and then now there is all these services now.
Yeah.
So how long did it take, and how many people are working on it in Clojure Codebase right now?
Sure. So we've been working full time on OK Let's Play for about 2 years.
Okay, that's pretty young.
And yeah, pretty young. I was doing some part time work before that, but full time for about 2 years. Right now we have 5 or 6 people in the company total, and then we have 2 software engineers who work with me. One focused on the front end, one focused on the back end, and then I just sort of go wherever I need to go.
Yeah.
And yeah, it's. Oh, actually, I'll talk a bit about that. I thought that I was surprised because I thought that hiring Clojure developers would be like, I knew it was going to be harder because there just aren't that many Clojure developers.
Yeah.
But I thought that by the nature of them being Clojure developers, that they would just be great. But we've actually had a really tough time hiring really good devs. We've had like a really low success rate in our Clojure devs, and that was a huge surprise to me, because I think that most people, like, you have to be a certain type of person to make it to Clojure, to have enough interest to learn the language, and then to stick with it, and then try to find a job with it. So that was a really big surprise for me, and I don't know why that is.
But is it the people that people that you didn't hire and the people that you hired? I mean, were they already Clojure programmers, or were they something like, okay, you're okay with having C++ people and you can get rid of C++ from their brain by brainwashing them into Clojure?
They were all already Clojure devs, and I think of the handful of Clojure devs that we brought on, we kept, like, of people who already knew Clojure, we kept one of them.
Yeah.
Because he's a really, 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 really great dev. But the other one that we have right now was a C++ dev, like another game dev, C++, and C#. And I just knew, like, he's a really solid dev. Clojure's not going to be a problem.
Yeah.
And so then I just had to sell him on being okay with his mind being blown for the first month. But it was really fun to see him struggle through that.
Yeah.
And like, he has a map and he like wants to update some stuff, or he has like a list of maps and he wants to turn it into one map. He wants to reduce it into one map.
Yeah.
Like, just seeing him be like, I know what I need to do, but I don't know how to do it. And and we'd do a lot of calls, and I'd just be like, oh, this is so cool.
Yeah.
But I mean, when I did that, as I said, like, I didn't have anyone to help me through it.
So what did you put it down to, though, Jay? Is it because people like are a bit, maybe it's a thing in, are you hiring in San Francisco, or are you doing remote hiring?
We are fully remote. Yeah. So we actually, 2 of us are in San Francisco, but one of us is in Brazil.
Okay. And so, just to loop back to the question that I was asking, so from C++ to Clojure, there is a significant, a paradigm shift. And for me, I feel like because I did a lot of Scala before, so I got used to Clojure, and then when I'm doing Rust, I feel like, what the fuck? I mean, if I call something, I get a different type, and there is no common data structures to deal with. I mean, because you also have experience with both Rust and Clojure,
right?
So how do you see the transition to Rust then? I mean, if you're working on Rust code? Sure.
Well, I was just talking to someone on IRC yesterday, actually, because I was in the Rust Freenode channel, and I said something. He's like, "Oh, aren't you the guy who made the Q3 thing?" And I was like, "Yeah, I'm popular." Like, one guy recognizes me on Freenode. But I was telling him, like, but I was like, I am, and he's like, "Oh, I thought you went back to C++. I was like, "I did." And I was telling him, like, yeah, back 5 or 6 years ago when I was writing Rust for Q3, I was really bad at Rust because I had what I had a C++ brain.
Yeah.
And everything that I was thinking of was just in terms of C++. And now that I'm writing Rust, I feel like I'm really bad at Rust still because I have a Clojure brain. And the thing is that now that I've done Clojure so much, at least my Clojure, like the Clojure the way that I want to do it is adversarial Clojure. I think of things in terms of data, right?
Yeah.
And everything is as much as possible anyway. Is declarative data pipelines.
Yeah.
And a lot of the, when we're discussing features at OK Let's Play with the other devs, we'll just share gists of maps. And that's the feature that we're talking about. It's like, okay, the data will look like this.
Yeah.
And then the transformations you need to do, those are kind of implied just by knowing how the feature is going to work.
Yeah.
And so doing that with Rust is really fucking difficult.
Yeah.
You can't.
It's crazy.
Because how do you have a heterogeneous map?
Yeah.
In general, you don't. And the other thing is what I found in this game server that I'm still working on now is I started using a lot of Rust enums for sort of it can be this or it can be this or it can be this, and it can have these different shapes. Yeah. But each time you match on one of them, it needs to be exhaustive.
Exactly, and then
which is exhausting.
Yes. That's totally true. Yeah.
It is really nice to be able to write that and struggle with the borrow checker until it compiles, and then be like, yes, and then it runs and it works.
Yeah.
And you don't need to worry about it. But And I would consider using Rust for some of our services on the back end, just due to the performance, due to the memory profile, everything like that. But for anything that we're doing with data, I just wouldn't do it. And honestly, it's the same thing with Haskell. I just wouldn't do it. For those languages that focus on the types, to me, it's just not worth it. And we have some services that are just focused on moving data through WebSockets from Mongo to our front end, for example, which is basically our own kind of Firebase, except it has a better permission system and it scales horizontally. That's just data. It's just moving data. And we need to handle different shapes of data. We need to be able to do it in a very fluid and flexible and what's the word that I want? Agile way. Yeah. And to do that in such a strongly statically typed language, I just don't think makes sense. I just don't think it's a good choice.
Yeah, I think time-wise and also investment-wise, I mean, there is too much design work that you need to do to make it as flexible as what you can do with Clojure.
Right.
And I think that's the challenge that I see now. I mean, I had the similar kind of thing on Scala versus Clojure when I was doing both when I was working on that one. But at least they both are on JVM, so I don't have to deal with this borrow checking and memory and shit. But now I'm kind of juggling between Clojure and Rust, and I'm like, okay, these are completely different way of thinking, and it's a bit
isn't it the way I think about it for these kind of low-level languages like C and Rust and stuff like that, and these other things, is that it's all to do with and I think Jay's kind of saying it as well, is it's the problem space. If the problem space is kind of well defined, and you know that there's a certain set of types coming in, going out, well, do you need all the flexibility that Clojure gives you when you can actually, the problem? It's not going to change that much. For a lot of network services, things are like that. They're fairly simple. Just take a packet in, give a packet out. The shape's not going to change that much. You don't need the fluidity. And in that case, I think these low-level languages can, like Rust, can offer a lot of value. But there are many services where it just doesn't make sense. If you have to talk to other kinds of APIs and this kind of stuff, where things are evolving, where things are changing quite a lot, where you need that agility that you're talking about.
Right.
But it's very difficult to make it kind of like a very simple line in the sand.
Yeah. But also it's the tooling, because one of the things that I totally miss if I'm writing in Clojure, you get used to REPL, and then there is a function, and then you just run it and then check it what it's going to do, and then move on.
Not if you're Jeaye, you don't.
So, but in Rust you can't do that. I mean, you have to run the whole fucking program, and then there is no way I can just test one. I mean, you can write tests and whatnot, but it's a different mode of writing code, I think, and once you get used to this organic way of developing code with function by function and then running it and then moving on, that doesn't work there. And then there is different priorities, different way of writing code. And totally.
No, I completely agree with you there, Ray. I think that if you do have a finite amount of like really well-known data shapes. If your domain is finite and well-known, then something like Haskell with servant, where you can just define the whole thing with types, or I'm using Rust with Actix, which basically does the same thing. And I just define an endpoint function that says this takes in JSON of some generic struct type that I've defined as serializable. And like it handles the whole well, if I can properly deserialize the JSON into this struct type, then I'll call the function. Otherwise, I'll give you a 400. And that can be really nice. You don't need to worry about it. And the thing is, as soon as you get into that endpoint function, you have valid data. Right. Whereas with Clojure, we need to do a lot more of that validation ourselves. Fortunately, we have spec, but still, it's rough.
But I think it's almost 90 minutes. So I think this would mean that we need to take you to the Rust podcast for the next episode.
We need an exit song soon.
Okay. Oh dear.
No, we're not gonna. So I was just thinking. I think the adversarial Clojure that you're going to write, I think we should name it like opener instead of Clojure. It's going to be opener, and that'd be like amazing.
Shutter, I think shutter is better.
I want to say a little bit about this, guys. It's called Idiolisp. Idio as in idiom, meaning like quirky. Because it's my Lisp. And it's very peculiar. It's very particular to my tastes. But what I basically want is the other thing I really disagree with Clojure about is the JVM. Coming from game development, like operating system development, I don't want the JVM. I want persistent immutable data structures. Lisp, that's great. Macros, those are great. But let me compile it to native code. The other thing is, let me have it be dynamically typed to start with. Let me write the most Clojure-y looking code to start with and have it compile to like C++ or LLVM or something like that.
Don't you think that like the Graal stuff will get you there eventually?
Kind of, maybe. I'm hoping so. But here's the thing. What I really want to do is then once you define specs for your data, right? Basically like spec, except once you define specs for data, that changes the way that it changes what the compiler knows about it. And all of a sudden, that's not a boxed object anymore. Now I know the type of that. Now I can better track that. Now I can better optimize that. And so you can write your data, you can write your whole fucking program to be dynamically typed, get it working, and then lock it down with specs. And by doing so, you optimize it as well. I don't see why this can't exist. I don't know of a single language which works this way, but it's exactly it's exactly how I want a language to work.
I think you're right in terms of like where it could go. I think obviously spec itself is still somewhat in a state of flux.
It's a long gestation period.
Right. It can't be spec. It can't be spec exactly because it can't be predicative even. It has to be something that is statically known. But anyway.
Yeah.
Well, yeah, it's an interesting idea. I think this concept of essentially being able to think about the binding forms and then essentially kind of like bind it all down. I think the one could argue that that's kind of what the JIT does, but like you say, it does it at runtime. It does it a bit later on.
Yeah,
and by the sound of things, you'd rather have that information early or that performance early rather than later. But I think the downside of not going with the VM, because the history of Lisp is littered with idiolisps, if you like. You could all call it short for idiot, actually, but
I had figured that the people who write that would be called idiots. I'm prepared for that one.
Sorry?
Hey.
I'm prepared for that one.
Okay, no, I'm joking. No, the reason I say it is because or the reason that people say that Clojure is a success, or that the reason why a hosted language is winning is because you get access to all of the other ecosystem material.
Yeah,
and that's the question is whether or not you get any value out of that. And I think probably for the whole Clojure community, the win is probably outweighs the loss, but per use case, maybe it's not worth it.
Right. I think that if you look at any library that is cross-platform, for like as in cross-host, so ClojureScript and Clojure CLR and Clojure JVM, it's basically just going to be pure Clojure, and you can get a lot done with just that. The other thing is that if you are compiling to native code, you can interface with just about anything through the C API.
Sure.
Right,
that's true.
And you can do that with basically no overhead. And I mean, and Graal has shown so much what you can do with that. So I think that you're absolutely right. There have been so many attempts. The other thing is that I'm not going to say that my language is going to be special or better than anyone else's in any way. I just hope that when I have enough time to finish it, that it's going to
change.
Just like my no. Fuck the world. Just like my Vim environment.
Welcome to Defen.
just like my Vim environment, it's made for me.
Right.
And Idiolist would be made for me.
Yeah. Makes sense.
Yeah, it's an interesting project, I think. I think it's in terms of, like you say, the ability to explore ideas and and just to kind of like see how far a particular idea can go. I think I mean, everyone's free to do this stuff. Why not?
Yeah.
So and just one before we kind of wrap up a little bit, I do want to say something that I've been impressed by, Jay. I mean, I like Orchestra, but the thing that I kind of knew you for before Orchestra was actually your blogging. I think you're doing a good service to the Clojure community there, actually, by the amount of blogging you do. Often find little answers. If I'm looking for something, I'll often go to your blog and you'll give a good long explanation of how things work. And it's I think you've taken some time out there, and I really appreciate that,
Thank you, Ray. That's I haven't done it in a year or so just because of the startup, but I really appreciate the kind words.
That's fair enough. No, but the contributions you've made in the past have been really, really good. So I think kudos to you for that. Top tip.
So it's time to wrap up then. It's been beyond 90 minutes. I hope we have covered, I think, just enough ground.
We might have to cut the song out from the beginning.
If it is actually in the thing. I need to check. So thanks. Probably.
Oh man, come on! We did 2 versions of it. We're going to have at least one.
So.
In
I mean,
I agree.
I mean, you can't rely on computers, as you know. So, fucking hell.
We might have to do this whole thing again.
Yeah, exactly. I think we need to redo this same shit. It's going to be like Broadway show. You just do the same play again and again and again, and then we're gonna song and sing this stuff.
Yeah, and we're gonna grow to hate each other.
Don't we already? I mean, at least Ray and I, we do. So.
Yeah, we
adversarial relationship.
Welcome to the club.
Relationship, calling it a relationship is a bit of a stretch, but yeah, I mean, we're acquaintances. We're okay. Yeah. But anyway, so thanks a lot, Jay, for joining our silly little podcast and talking about all the serious shit. And it's really nice to know that how you progress through, I mean, having such difficulty and then making a successful career out of it. And obviously, becoming a CTO for a startup must be extremely exhausting and also exciting, I would guess. And getting to do that in Clojure, and I mean, I'll excuse you for VI, but anyway, I mean, rest of the stuff seems to be okay.
Yeah, it's you're right on all those points.
Wow.
And thanks for having me on.
You're really editorializing at the end here, mate. You know, your life seems to have been worth it,
except
Jay.
for the Vim part. But we'll leave that out of the
Except for
eulogy.
VI. Yeah.
Good riddance.
I think
he would have been great if it wasn't for
exactly.
VI.
9 out of 10.
After 90 years or so, that is what something that's we're gonna write down on your what do you call that? The thingy that stone or whatever.
Tombstone.
Tombstone.
Gravestone.
Yeah. He was a VI user. Yeah. Okay.
Yeah.
But
All right.
thanks, man. I think thanks for all the information, and hopefully, I think you'll continue with adversarial closure, and maybe come back again to talk about this stuff again.
That would be great. Thanks so much, guys, for having me.
Thank you. That's
It's been an absolute pleasure. Cheers, Jay.
that's it from us. Bye bye.